i-off yung inyong camera. Okay, so once again, good evening everyone. So,
Good evening din.
Good evening po.
Good evening po.
what we're going
Good
to do
evening po.
first is to discuss about the basic. No, we start from the very beginning because maybe somebody, especially for those who graduated for almost 10 years, no, and you don't have any exposure with the statistics. So maybe there's something we need of the statistics. Okay, so again, if you have some questions related to statistics or related to my discussion, do not hesitate to post your question in our chat box. Okay, kindly listen, and if you have some questions, comment do not hesitate to post your question in our chat box.
Sir, nawawala po.
So for most people, the sheer mention of the word statistics causes much anxiety. No? They think of it as a collection of numbers and formulas that have vague meanings. Actually, without noticing it, people often apply statistics in their everyday lives. When a clinician records the result of a physical examination of a patient, he is collecting data to aid the physician in diagnosing the type of illness the patient has and to determine the appropriate medical treatment that must be prescribed to the patient. In some other way, when a teacher records the examination scores of the student in a particular subject, he is recording data which he can use later on to determine if his method of teaching has been effective, to find out how well the student performed in the test, or to know the degree of ease or difficulty of the test. So when watcher of a basketball game talk about the number of rebounds and assists done by a player, they talk or they are talking about some vital statistics of the game. Okay, so what we're going to do first is to discuss the basic concepts. Now, so maybe somebody are asking what is the definition of statistics, no? So, statistics is a branch of applied mathematics that deals with the collection, organization, presentation, analysis, and interpretation of data. Statisticians, no, develop and apply appropriate methods in collecting and analyzing the data. They guide the design of research study and then analyze the results. The interpretation of the results will be the basis of the statistician in making references about the population being considered. In some sense, it is a collection of methods for planning experiments, obtaining data, and then analyzing, interpreting, and drawing conclusions based on the data. So, we have two aspects of statistics. So, we have the theoretical and applied. So, when we say theoretical, it deals with the development, derivation, and proof of statistical theorem, rules, and laws. While applied involves the application of theorems, rules, and the laws to solve the real-world problems. So data are the values that the variables can assume, where the variable whose values are determined by chance are called random variables. We have different types of categorical, na? So, categorical or qualitative variables are variables that are classified according to some attributes or categories. Are words or codes that represent a class or category. The categories may be, so example, of course, is the gender, eye color, political preferences, religion, blood type, civil status, year level, course, profession, and socioeconomic status. The categories may be ordered, but specific numerical values may or not be assigned. Some example are as follows. So performance rating, poor, fair, good, very good, excellent. For IQ score, low, average, high, public opinion about the performance of president. For example, what is the president's are classified according to statistics. So example, height, age, pulse rate, number of children, and speed. Numerical valued variables can be treated as categorical variables when they are grouped into class interval. So example, age in years. For example, 5 to 9, 10 to 14, 15 to 19, and 20 and above. Height in centimeter, for example, 100 to 149, 150 to 199, 200 to 249. Another example, grade in math, for example, statistics, 1 to 1.49, 1.5 to 1.99, 2 to 2.49, 2.5 to 2.99, 3 to 3.49, and 350 to 3.99, and 4 to 5. Numerical valued variables can be classified as follows. So we have what we call discrete variables and continuous variables. So when we say discrete variables, that is a variable whose values are obtained by continuing or by counting. So example, number of children, number of person with blue eyes, number of patients with TB, or number of males and females in a statistics class. So that's an example of a discrete variables. When we say continuous variables, are variable whose values are obtained by measuring like temperature, distance, area, density, age, height, and weight. No? So all of which cannot be put into a list because they can have any value in some interval or a real values. Okay, so we have type of statistics. And of course, all of us are familiar with descriptive and inferential statistics. Okay? So, descriptive statistics, as what we have here, deals with the collection and presentation of data and summarizing values that describe the group's characteristics. The most common summarizing values are the measure of central tendency and variation. One can describe the performance of a class of 40 students, for instance, using the mean score in the given examination in college, algebra, or statistics. Suppose the mean score is 56 and the passing score is 45. Then one can say that majority of the students pass the test. If only 12 out of 60 students obtain scores above 45, then it means that the exam is too difficult or the teaching strategy was not effective. So either the teacher has to exam or reteach the topic. When we say inferential statistics, it deals with prediction in inferences based on the analysis and interpretation of the results of the information gathered by the statistician. Some of the common statistical tools of inferential statistics are t-test, c-test, analysis of variance or ANOVA, chi-square or chi-square, and person R. So again, when we say inferential statistics, uh, we define the following terminologies. So population is the complete and entire collection of elements to be studied. It is defined as a group of people, animal, places, things, and idea. We have also what we call parameter. So the parameter is a numerical measure that describes a characteristic of a population. It is a numerical measurement describing some characteristic of a population. So sample, it is a subject or it is a subset of a population or part of a population. A subgroup of electricity bills of the resident in Tingloy, Batangas is 15,000. The population statistics. Now, statistics is a numerical describing some characteristic of a sample. So, example, as I mentioned earlier, no? Now, so a collection of data. for selecting the best method to be the type of data, the time allotment to complete the study, and the researcher's financial capacity. Some common method of data collection or interview tests, experiment, registration, and use of mechanical devices. So, the different methods of collecting data are as follows. So, number one, of course, is interview. So, what is interview? An interview is a conversation for gathering information. A research interview involves an interviewer who coordinates the process of the conversation and asks questions, and an interviewee who responds to those questions. Interviews can be conducted face-to-face or over the telephone, and the internet is also emerging as a tool for interviewing. When is an interview an appropriate research method? So interviews are an appropriate method when there is a need to collect in-depth information, people's opinions, thoughts, experiences, and feelings. Interviews are useful when the topic of inquiry relates to issues that requires complex questioning and considerable proving. Face-to-face interview are suitable when new target population can communicate through face-to-face conversations better than they can communicate through writing or phone conversation. So example, children, elderly, or disabled individuals. So types of interview. Interview can be designed differently depending on the needs being addressed and the information. So they can be grouped into three types. So structured interview. The interviewer asks a set of standard, predetermined questions about topics in a specific order. The respondents need to select their answers from a list of options. So the interviewer may provide clarification on some questions. Structured interviews are typically used in surveys. Semi-structured interview. The interviewer uses a set of predetermined questions and the respondents answer in their own words. Some interview interviewers use a topic guide that serves as a checklist to ensure that all respondents provide information on the same topics. The interviewer can probe areas based on the respondent's answer or ask supplementary questions for clarification. Semi-structured interviews are useful when there is a need to collect in-depth information in a systematic manner from a number of respondents or interviewees like teachers, community leaders. Number three is unstructured interviews. The interviewer has no specific guidelines, so restrictions, predetermined questions, or list of options. The interviewer asks a few broad questions to engage the respondent in an open, informal, and spontaneous discussion. The interviewer also probes with further questions and or explore inconsistencies to gather more in-depth information in the topic. Unstructured interviews are particularly useful for getting the stories behind respondents' experiences or when there is a little information about a topic. So, as what we have here, define your objectives. So, identify what you want to achieve and information you need to gather and make sure an interview is the appropriate way to meet your objectives. Choose the type of interview. So, review your required information, budget, time, and potential respondents, and decide whether you need to conduct structured, semi-structured, or structured interviews. Choose the appropriate respondents. Okay, depending on the type of interview, decide on the characteristic of interviewees and the number of interviews required. Decide how you will conduct the interview. Consider telephone or face-to-face interviews. For large surveys, consider computer-aided interviewing and recording like Google Form and others. So, decide how to recruit your respondents. So, obtain contact information. Decide how you will record the interview. So, depending on the type of the interview. Make a list of questions and test them with a sample of respondents. So, the question must be aligned with the type of interview. And decide who will conduct the interview. Develop an information kit that includes an introduction to the research topic and instructions. So, steps in conducting an interview. So, before the interview, define your objectives. Okay? Then, choose the type of interview. Choose the appropriate respondents, of course, depending on the type of interview. Decide on the characteristics of interviewees. Decide how you will conduct the interviews. Decide how to recruit your respondents. And decide how you will record the interviews. Make a list of questions and test them with a sample of respondents. Decide who will conduct the interview. During the interview, introduce yourself and initiate a friendly but professional conversation. Explain the purpose of your project, the importance of their participation, and the expected duration of the interview. Be prepared to reschedule the interview if a respondent has a problem with the timing. Explain the format of the interview and tell respondent how the interview will be recorded and how the collected information will be used. If possible, obtain the written consent to participate in compliance with data privacy policy. Ask respondent if they have a voice and language. Keep the focus on the topic of inquiry and complete the interview within the agreed time limit. Ensure proper recording and complete the sessions. So after the interview, make sure that interview. So questionnaire. So a questionnaire is a list of well-planned questions, no, written on paper, which can be either personally administered or mailed by the researcher to the respondent using any of the following forms. Type, and we have a recall type. Recognition type, so the ability to match a piece of information or a stimulus to a stored image or facts. Possible answers. We have multiple choice type, of course, and a multiple response type. So, and another, of course, is the free response type. Our final category question is those where the student is not presented with the choice, but it is shown a blank box into which text or numbers are entered. Respondent feedback in a comparative form for a specific features, products, or services. Test method. widely used in psychological research and psychiatry. Standard tests are used. We need to always to prove the validity, the reliability, and usability of your method. So, of course, example of data gathering using this method are those that are obtained from the Philippine Statistics Authority, LTO, CHED, TESDA, and so on. Mechanical devices. It can be used when gathering data for social and educational research are the camera, projector, videotapes, tape recorder, and so on. And a lot more actually at present, especially at present. Techniques. Before the collection of data, it is necessary to determine the sample size if the population is very large. For instance, if a researcher wants to find the average IQ of the Filipino children aged 5 to 7 years in the rural areas, and he has only a few months, no, to spend for collecting data, sampling is allowed to save time and money. So, when to use Slobin solution, a formula must be used to take into account confidence levels and margins of error. When taking a statistical sample, sometimes a lot is known about a population and sometimes a little and something nothing at all. So for example, we may know what may we know that a population is normally distributed. We may know that there is a bimodal distribution, or we may have no idea about how a population is going to behave. So Slobin's formula is used when nothing about the how to use Slobin formula as what we have here. Of tolerance to B. So, scenario. Before the collection I mentioned earlier, okay, based on to compute for the sample over 1 plus NE or squared, no? Where N, lower N, not given. Sometimes we use 0.5. Now, Jesus wants to know the average income of Barangay San Jose, which has 25 residents. Calculate the five as what we have here. N. So we're looking for a sample size. Raised to 2. Now, survey would be meaningless and at. So the best survey design practices keep the target population at the core of their thought process. All the residents of the, for example, no, as what we have here. So when the population is small enough, research called a census. However, most surveys cannot survey the entire population. This is when sampling techniques become crucial to your survey. Why is it important? Okay? Research constraint, if the target population is not small enough, or if the resources at your disposal don't give you the bandwidth to cover the entire population. It is important to identify a subset of the population to work with, a careful identified group that is representative of the population. This process is called survey sampling, and it is designed. Whatever the sample size, there are fixed costs associated with any survey. Three features to keep in mind while constructing a sample. So, of course, number one is the consistency, transparency. Okay, again, so this will be the three features to keep. Number one, of course, is the consistency. It is important that researchers understand the population on a case-to-case or case-by-case basis and test the sample for consistency before going ahead with the survey. Number two, of course, is diversity. Ensuring diversity of the sample is a tall order, as reaching some portions of the population and convincing them to participate in the survey could be difficult. And the other one is transparency. There are several constraints that dictate the size of the structure of the population. Okay, it is imperative that researchers discuss these limitations and maintain transparency about the procedures followed while selecting the sample so that the results of the survey are seen with the right perspective. Probability sampling techniques. So when each entity of the population has a definite non-probability sample, the probability of the population, they provide the most valid and credible results because they reflect the characteristic of the population from which they are selected. So number one, of course, is the random sampling method. So I have an example here. And use case. So you need to consider when and how and what will be the cons and use case of the random sampling. So systematic sampling, it is a type of probability sampling method in which members from a larger population are selected according to a random starting point. Okay, this interval called the sample size. So when sample size, arrange the elements of the at regular intervals from the list. This will be the pros and cons in using a systematic sampling techniques. For stratified sampling, it is applied when the population is divided into different strata or classes, wherein each class must be presented in the study. If a population has distinct group, it is possible to divide the population into these groups and to draw SRs from each group. So the group are called strata, and strata are designed so that the member in each strata are more homogeneous, that is similar to each other. So when do we use the stratified sampling and how? I have an example here. And what will be the pros, cons, and use cases of a stratified sampling techniques? The three non-probability sampling techniques include convenience sampling, snowball sampling, and quota sampling. So when we say convenience sampling, it is a specific type of non-probability sampling method that relies on data collections from population members whose sampling method that, of course, conveniently available to participate in the study. Like Facebook polls or questions can be mentioned as a popular example for convenience sampling. So another, of course, definition of convenience sampling. So when and how, what will be the pros and the cons. For snowball sampling, it is where research participants recruit other participants for a test or study. It is used where potential participants are hard to find. So it's called snowball sampling because once you have the ball rolling, it pick up more snow along the way and become larger and larger. So this will be when do we use the snowball sampling, how, what will be the pros and use case in using snowball sampling techniques. And the other one is the quota sampling. Okay, so this method used in TAC groups called cluster. So it is a non-probabilistic sampling. It controlled quota sampling involves introduction and uncontrolled quota sampling. So when do we use? How do we use? What will be the pros and use case using quota sampling techniques? Now, maybe you are also familiar with summation notation. Open mathematical formulae required the addition of many variable summation or sigma notation is a convenient and simple form of shorthand used to give a concise expression for a sum of the values of a variable. So, summation notation involves, of course, the summation sign, the appear as the symbol S, and so on. So, the variable which is being summed and the index appear as the expression is I is equal to 1. So summation notation involves the starting point of the summation for the lower limit of the summation, the stopping point for the summation or the upper limit of summation. So as what we have here, we have the stopping point, upper limit of summation. So that is an n. Then x sub I, that is type of elements. Summation sign, of course. Index of summation, that is x is equal to 1. And 1 is the starting point, lower limit of a summation. So some typical example of a summation, no? So this expression means sum of the values of x is starting at x sub 1 and ending with x sub n. So as what we have here, no? So x sub 1 plus x sub 2 plus x sub 3 plus that is on so far to x sub n. Then the limit of summation are often understood to mean I is equal to I through n. So the notation below and above the summation sign is omitted. Therefore, this expression means sum the values of x starting at x sub 1 and ending with x sub n. So, as what we have here, the expression of the sum, the square values of x starting at x sub 1 and ending with x sub n. So, arithmetic operation may be performed on variable within the summation. So, as what we have here, we have an example. And the arithmetic operation may be performed on expression containing more than one variable. So, we have also an example for that. So, to calculate based on the given, of course, summation of 4, 3 sub I, wherein I is equal to 1. So, first notice that I is equal to 1, then 2, 3, and 4, we are supposed to multiply each of these 3 and add them up. So based on the given formula, so 3 times 1, 3 times 2, 3 times 3, plus 3 times 4. So if we're going to multiply this one, that is 3 times 1 is equal to 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So therefore, the answer is 30. So for the formula for the sample mean, sometimes called the average. So we have a formula, of course, here. X is our the mean, no? So example, a survey was conducted asking 8 older adults how many sexual partners they have had in their lifetime. So we have a given sample here. So 4, 12, 1, 3, 4, 9, 24, and 7 for the 8, no? 8 older. Use the formula to find the sample mean. So as what we have here, this will be the formula as what we have a while ago. So if we replace that x sub 1 to 8, of course, x sub 1 is 4, x sub 2 is 12, based on the given, no? And we have 8 older adults. So this will be 8. If we're going to sum up, no, this 4, 12, 1, 3, and so on, that is equal to 64. So now that we have the numerator calculated, the formula tells us to divide by n, which is just 8 as what we have here, no? So mean is equal to 64 over 8, that is mean is equal to 8. Okay? So the next most important statistics in the standard deviation, the formula for the sample standard deviation is as what we have here. So let's consider the data in the previous example. So based on the given, no? So we have compute the 8 subtraction. So the next arithmetic to do is to square each of the difference to get this one. Okay, so negative 4 is equal to 16. 4 squared is equal to 16. Negative 7 squared is 49, and so on and so forth. Now we have all the entries in the summation, so we add them all up. Then now we can write, no, that is 380 over 8 minus 1. That is 380 over 7. Then square root of 380 over 7. That is 7.38. That this will be the standard, no, this will be the square, no, of the given value. Okay. Okay, so that this will be the first part of our discussions on the basic concept of statistics. Again, what will be the next, of course, is on how we'll be able to understand on how we can, of course, on how we can organize and present the available data. Okay? Presentation. Data gathered can be made more interesting and organized by presenting them in the form of graphs and tables. Readers may not appreciate reading a statistical report on the current population of different countries in the world if the report is just a list of numbers from one paragraph to another. The different types of data in the various ways of collecting them were presented. So the different sampling methods were also discussed. No? So in this lesson, you will learn how to present the data in tabular or graphical forms. The tabular the tabulated textual form of presenting data will no longer be discussed. The data types are the frequency distribution, correlated data, and time series data. There is no need to conduct the frequency distribution table if the number of observation is less than 30. Again, there is no need to construct the frequency distribution table if the number of observation is less than 30. Data that are presented in a frequency distribution table are called group data, while those that are not are called ungrouped data. Okay, so again, this topic is under lesson 3 for the probability in statistics. So, what is research data? So, research data is any information that has been collected, observed, generated, or created to validate original research findings. Although usually digital research data are includes non-digital formats such as laboratory notebooks and diaries. So, as what we have here, we have types of research data. We have a document spreadsheets, laboratory notebooks, field notebooks, diaries, questionnaires, transcripts, code books, audio tapes, video tapes, photographs, films, and of course, the test responses. So slides, artifacts, specimen samples. We have collections of digital data files, database contents like video, audio, text images, models, algorithm scripts, content of an application like input, output, log files for analysis, software, simulation software, and schema. So, okay. So when it comes to non-digital data such as laboratory notebooks, I-score samples, and sketchbooks are often unique. You should assess the long-term value of any non-digital data and plan how you will describe and retain them. You could digitize the materials, but this may not be possible for all types of data. So we have the sources of data. So research data can be generated for different purposes and through different processes. So we have observational data, experimental data, derived or compiled data, and reference or canonical data. The presentation of data. It is the utter importance nowadays. So after all, everything that is pleasing to our eyes never fails to grab our attention. Presentation of data refers to an exhibitions or putting up data in an attractive and useful manner such it can be easily interpreted. The three main forms of presentation of data are textual presentation, of course, data tables, and diagrammatic presentation. So when it comes to textual presentation, of course, this kind of presentation is useful when we are looking to supplement qualitative statements with some data. So it's just to have a statement that serve as a fitting evidence to our qualitative and helps the reader to get an idea to scale the phenomenon. So for example, no, so the 2002 earthquake proved to be a mass murderer of humans, as many of 10,000 citizens have been reported dead. So therefore, the textual representation of data simply requires some intensive reading. And this is because the quantitative statement just serve as an evidence of the qualitative statements, and one must go through the entire text before concluding anything. So, if the data under consideration is large, then the text matter increases substantially. As a result, the reading process becomes more intensive, time-consuming, and cumbersome. So, data tables or tabular presentation. A table facilitates representation of even large amounts of data in an attractive, easy to read, and organized manner. So the data is organized in rows and columns, and this is one of the most widely used forms of presentation of data since data tables are easy to construct and read. So when we say row, that is horizontal. When we say columns, that is vertical. So the components of the data table, of course, we need to have a table number. Okay? Title, of course. It must be contain a title that clearly tells the readers about the data. It contains time of period of study, place of study, and the nature of classification of data. Head notes, of course. Head notes present the units of data in brackets at the end of the table title. Then the stubs, no? These are the titles of the rows and the tables in the table. Okay, and of course, we have also a caption, no? Wherein the title of the column in the data table. So it is a counterpart if a tab and indicates the information contained in a column. Then body field, of course. The body of a table is in content of a table in its entirety. Each item in a body is known as a cell. So actually in Microsoft Excel, that is what we call active cell. A combination of a row and column. Of course, another component, footnotes. Footnotes are rarely used. So in effect, they supplement the title of a table if required. Then we have source, no? So when using data obtained from a secondary source, this source has to be mentioned below the footnote. Construction of data table. So there are many ways of construction of a good table. However, some basic ideas are the title should be in accordance with the objective of the study, the comparison, alternative location of tabs, headings, the footnote, of course, and size of columns wherein it must be uniform and symmetrical. Use of abbreviation, headings and subheadings should be free of abbreviation, no, for the readers to understand the exact terms, no, that we indicated in our headings. Units, there should be a clear specification of units above the column. So we need to specify clearly the units. Now, what are the advantages of the tabular presentation? Of course, number one is of representation. So a large amount of data can be easily confined in a data table. So it is a simplest form of data presentation. Ease of analysis, no? Used for statistical analysis like calculation of central tendency or dispersion and others. Helps in comparison. So the rows in columns which are required to be compared can be placed next to each other. So to point out, this facilitates comparison as it becomes easy to compare its value and economical. Okay? So the data in a manner which is really easy on the eyes of a reader. It saves time as well as space. Okay, so classification of data in tabular presentation. So we have qualitative classification. So data in a table is classified on the basis of qualitative attributes. So in other words, if the data contain attributes that cannot be quantified like rural urban, boys, girls, and others, it can be identified as a qualitative classification of data. So based on what we have here. Then the quantitative classification, data is classified on basis of quantitative attributes like marks, the 0 to 50, no? So as what we have here, so for example, that is 0 to 50, that is 29 number of students. For 51 to 100. For example, we have 64 number of students. Then, we have also what we call temporal classification. When the data is mentioned with respect to different time frames, we term such as classification as temporal. So, for example, as what we have here by 2016, no? So, we have 10,000 sales. In 2017, we had 12,500 sales. And that is an example of a temporal classification. How about the spatial classification? When the data is classified according to a location, it becomes a spatial classification. So, for example, we have a country and number of teachers here. As presented, no? So, we have 139,000 for India and 43,000 for Russia. Now, the difference between group data and ungroup data. So, maybe you're asking, what is group data and ungroup data? The word data refers to information that is collected and recorded. It can be in the form of numbers, words, measurement, and much more. Again, there are two types of data, and these are qualitative data and quantitative data. The difference between the two types of data is the quantitative data is used to describe numerical information. For instance, the measurement of temperature would fall under this kind of data. On the other hand, qualitative data is used to describe information in words after collecting data. It needs to be organized, hence the need to separate group data from ungrouped data. But both are useful forms of data, but the difference between them is that ungrouped data is a raw data. No? This means that it has just been collected but not sorted into many or into any group or classes. Group data is data that has been organized into groups from the raw data. Okay, so this will be a group data. So it is the type of data which is classified into groups after collection. Okay? So for example, when a test is done, the results are the data in this scenario. And there are many ways to group this data. So the number of students that scored above each 20 mark can be recorded. So as what we have here, the grades can be used, for example, a 90 to 100 all the way to 0 to 59. So with each category showing how many students are in each category. So histogram and frequency table are best used to show and interpret group data. So here is the example of a histogram of data. So range size is equal to 25. So 1 to 26, 26 to 650, 21 to 56, and so on. So, grouping of data has the following advantages, no? Helps improving the efficiency of estimations. It allows for greater balancing of statistical power of test of the difference between strata by analyzing equal number from strata. Irrelevant subpopulations are ignored while the significant ones are on focus. So, what is ungrouped data? Actually, it is also known as raw data. So, data that has not been placed in any group or category after collection. So, the number of individuals residing in that area is ungrouped data or raw information because nothing has been categorized. We can therefore conclude that ungrouped data is data used to show information on an individual member of a sample population. So, what are the Okay, some of the advantages of ungrouped data are as follow. Most people can easily interpret it. When the sample size is small, it is easy to calculate the mean, mode, and median. So it does not require technical expertise to analyze it. Okay? The classification of group data versus ungrouped data. The group data is data that has been organized in classes after its analysis. So example include how many bags of maize collected during the rainy season were bad. On the other hand, ungrouped data is data which does not fall in any group. It is still a raw data. The preference of group data. Ungroup data is preferred because it remains in its original form. It has not been tampered with classification or subdivision. However, when analyzing it in drawing graphs, group data is preferred because it is simple to interpret. Accuracy. Of course, when calculating the means of group and ungrouped data, there will be a variation. The mean of group data is preferred because it is more accurate as compared to the mean of ungrouped data. The mean of ungrouped data may lead to wrong manipulation of the median. Therefore, it is considered inefficient in most cases. For representation, frequency tables are used to show the information of group data, whereas in the case of ungrouped data, the information appears like a big list of numbers. And this is due to the fact that the information is still raw. So this will be the table of group data versus ungrouped data. So you could able to see the differences, group and ungroup, classification, preferences, accuracy, presentation, and of course, the summary. So, of course, in statistics, the term data is used to refer to information that has been collected and recorded to the purpose of specific projects, and it could be either qualitative or quantitative. So, frequency distribution. So, a graph or data sets organized to show the frequency of occurrence of each possible outcome to a repeatable event observed many times. Frequency distribution can be graphed as a histogram or pie chart. So, for large data sets, the step graph of a histogram is often approximated by the smooth curve of a distribution function or called a density functions when normalized so that the area under the curve is 1. The So the most convenient way of organizing data is by constructing a frequency distribution, of course. Because a frequency distribution is a collection of observation produced by sorting them into classes, ensuring their frequency or numbers of occurrence in each class. And we have three basic types, no, of frequency distribution. We have categorical, ungroup, and of course the group. So this will be the steps, no? The most important, you need to find the range, no? Of course, R using the formula. So R is equal to highest score deducted to lowest score. Then compute for the number of intervals N by using the formula. N is equal to 1 plus 3.3 log N. So where lowercase n is the number of class intervals, uppercase N a population or total number of observations. Then compute for the class size I using the formula I is equal to R over N. Using the lowest score as lower limit, add I is minus 1 to it to obtain the higher limit of the desired class interval. So the lower limit of the second interval may be obtained by adding the class size to the lower limit of the first interval. So add I is equal to 1 to the result to obtain the higher limit of the second interval. You may repeat the step 5 to obtain the third class interval and so on and so forth. So, when the n class interval are completed, determine the frequency of each class interval by counting the elements. Number 1, construct the frequency distribution table of the data below. So, as what we have here, so age of the COVID-19 patients in CVY hospital, for example, in January 2021. So, we have given a number, no? So, that is of the COVID-19 patient in CBY hospital. Okay? So, step 1, okay? So, as what we have earlier, you need to find the highest lowest score to highest score to and lowest score. Then, as what, based on the given example earlier, we have 60 as the highest and 6 as the lowest. So, 60 minus 6 is equal to 54. Step 2, compute for the number of intervals. So, n is equal to 1 plus 3.3 log 36. Why 36? Because the given data a while ago, or given occurrence actually a while ago is equal to 36. That is n is equal to 6. Compute for the class size I is equal to 54 divide 6. Because we have the range 54 and our n is 6. So, for us to get the class interval, of course, the class size I is equal to range minus n. Okay, so therefore the answer is 9. Now, since the lowest score is 6, this becomes the lower limit of the first class interval. The higher limit of this interval is 14, which is obtained by adding 9 minus 1 or 8 to 6. Because 9 minus 1 is 8. Then, a while ago, our lowest score is 6. So, the lower limit of the second interval is obtained by adding 9 to 6, and the higher limit by adding 8 to the result. 6 plus 9 is equal to 15. So, 15 plus 8 is equal to 23. So, the lower and upper limits of the third interval and the next intervals are obtained using the same steps or procedures. So, tally marks are used to aid in counting the elements of each interval. Then, the corresponding frequencies are obtained by counting these tally marks. The total frequency must tally with uppercase n, and the total number of observations. So, the high score is not included in the 6th interval. Consequently, it is necessary to add one more interval. So, age of patient a while ago. So, as we presented the occurrence a while ago. So, as I mentioned, we started from 6 because our lower score is 6. Then, a while ago, we have 8 plus 6, that is 14. That's why 6 to 14. And so on and so forth, up to 60 to 66. Now, so if we count how many numbers or occurrence fall in 60 to 66, that is 1. For 51 to 59, that is 2. 42 to 50 is 3, and so on and so forth. The n is 36 as what I mentioned earlier. Okay, so example number 2. So the following data given by the result of a sample survey of textbook track students in Holy Face of Jesus, Lyceum of San Jose Incorporated. The letters A, B, C represent the categories. So solution. So how many A's, how many B's, and how many C's? Total number is 30. So 6 A's, 9 B's, and 15 C's. If we're going to tally the given letters presented in table 4 a while ago. Okay, so making a frequency distribution and histogram. To show you how to do this, we will be using the data set below. So we went ahead and put the numbers in order, which will make everything much easier. So, okay. So steps to making your frequency distribution. Calculate the range of the data set. So range is equal to 65, the highest score. Then the lowest score is 12. So 65 minus 12, that is 53. Divide the range by number of each group you want and then round off. So let us say that we choose to have 6 groups. So if we do this then, 53 divided 6, that is 8.8. So again, we will round this up to 9 just because it is easier to work with that way. Okay? In general, people who are doing this by hand always round up even if was 8.1. Okay? So steps to making your frequency distribution is use the class with to create your group. So we are going to start at the smallest number we have, which is 12. Diba? As what we did a while ago. And count by 9. So 12 plus 9, that is 21. Until we have 6 groups. So as what we have here. So this will be the first group, second group, third, fourth, 5, and 6 groups. Okay, so table number 7. So that last table is our frequency distribution. To make a histogram from this, we will use the groups of the horizontal axis and the frequency on the vertical axis. And we will use bars to represent the frequency of each individual group. So with this data, the finished histogram will look like the one below. So this will be the histogram data of data. Okay, so how about class marks? So the class midpoint, no, or class mark is a specific point in the center of the bins or categories in a frequency distribution table. It is also center of a bar in a histogram. It is defined as the average of the upper and lower class limits. The lower class limit is the lowest value in a bin, a particular category. Then the upper class limits are the highest values that can be in the bin also. All members of the class are represented by their class marks when calculating most statistics for a frequency distribution table. In calculating the midpoint, you need to know the class limits for your data in order to calculate the midpoint. If you do not know how to find class limits, okay, see the steps in how to make a frequency distribution table a while ago. So this will be an example. Find the midpoint for class limits of 182 and 199. So the average of the class limit is 180 plus 199 divided 2. That is 89.5. This is your midpoint. Okay, you might see the class mark defined as the average of the class boundaries as well. And you will get the same results. So the same bin might have class boundaries of 179.5, 199.5, giving the 1.79.5 plus 199.5 is equal to 189.5 also. Okay? What if I have open-ended classes? So, again, as what we have here, it is a midpoint of a class interval. So, to obtain this point, add the lower limit and upper limit, then divide by the sum of 2. So, in our table number 3 a while ago, ages of patient in CBY hospital, for instance, the class mark of the interval will be as follows. So, 51 to 59, that is 51 plus 59 divided 2. So, therefore, the answer is how? Then 60 to 69, of course. Okay, so 60 plus 68 over 2 is equal to 64. While 51 to 59 is 51 plus 59 divided 2 is equal to 55. So, frequency distribution of the patient. So, 60 to 66 is 1. 51 to 59 is 2, class marks, and so on and so forth. So, how about the class boundaries? So, the class boundaries are the data values which separate classes. They are not part of the classes or the data sets. So, as what we have here, no? So, there are also known as exact limits and can be obtained by subtracting 0.5 from the lower limit. So, as you can see here, if we have 60, no? 60 here. So, in lower class, minus 0.5 is 59.5. In the upper class, plus 0.5. So, 66 plus 0.5, that is 66.5, no? And so on. So, for 51, that is 50.5. For 59, that is 59.5. Up to 6, that is 5.5 minus 0.5, of course. Then 14.5 for 14. That is plus 0.5. Again, lower class boundary is minus 0.5. Upper class boundary is plus 0.5. Example number 3, when 40 students were surveyed at Holy Face of Jesus, they reported the distance they drove to the school. So, in the results in kilometers are given below. So, solution, follow the steps. The number of classes is 8. Then, range is equal to highest minus lowest. That's 40 minus 1 is equal to 39. Class width is range, divide classes. That is 39 divide 8. That is 4.875 or 5. Determine the lower limit. Subtract 1 unit from the lower class. Limit and second class to obtain the upper limit of the first class. So, 6 minus 1 equals 5. So, then add the class width to the get succeeding upper class limit. So, 1 to 5. So, 6 to 10. 11, 15. Up to 36 to 40. Ay, ito. So, we determine the class boundaries. Okay? So, 1 is 0.5. That is class boundary. So, lower limit and upper limit. No? So, minus 0.5 to the lower limit and plus 0.5 into the upper limit. Okay, so total the scores or tally the scores. So, as what we have here, no? So, the tally marks, no? So, we count. So, make the frequency distribution table. So, we have the frequency, how many numbers from 1 to 5, that is 11, 6 to 10, that is 9, and so on and so forth. Okay, so a variation of the standard frequency table is used when cumulative totals are desired. So, the cumulative frequency for a table whose classes are increasing order in the sum of the frequency for that class and all previous classes. So, how to get the cumulative frequency? So, as what we have here, so 11, that is 11. Frequency 11 is cumulative frequency 11. Then 11 plus 9, that is 20. 20 plus 6, that is 26. 26 plus 5, that is 31. 31 plus 6, that is 37. 37 plus 0 equal to 37. 37 plus 2, 39. 39 plus 1 is equal to 40. That is the way on how we'll be able to get the cumulative frequency. Okay? So, correlated data. The correlated set of data is a table where two or more frequencies are shown for easy comparison. If one wants to compare the number of cases according to age, then total frequency will be the sum of the frequencies of the male and female patients per each group. A new table may be formed as follow. So, for example, based on the given example a while ago, no, on our age of patient in CVY Hospital in January 2021. So, for example, age 60 to 66, 1 female and 0 male. So, therefore, the total frequency is 1. 51 to 59 years old, that is 1 male, 1 female. That is the total frequency of 2. For 40 to 50, 1 male, 2 female. That is a total frequency of 3. 33 to 41 years old, 2 male, 0 female. That is 2, the total frequency. 24 to 32, that is 13 for male, 7 for female, that is 20, and so on and so forth. So as you can see here, we have a total of male that is 19, a female that is 17, and the total frequency is 36. So in this table, the data are grouped according to religion and sex. So one can say that 70% of the male and 60% of female in the distribution belong the region A, and 30% of the male and 40% of female in the distribution belong to a region B group. Okay? So as what we have here. Okay, so how about the time series? So this is opposed to cross-sectional data which observed individuals, companies, and others at a single point in time. The statistical characteristic of time series data violate the assumption of conventional statistical methods. So because of this, analyzing time series data requires a unique set of tools and methods. So what is the example of time series data? So as what we have here for economics, social science, epidemiology, medicine, and physical sciences. So the time series data is collection of quantities that are assembled over even intervals in time in order chronologically. The time interval at which data is collection is generally referred to as the time series frequency. So, the time series graph above plot the visitors per month to Yellowstone National Park with average monthly temperature. So, the data ranges between January 2014 to December 2016 and is collected at a monthly frequency. So, this will be the time series visualizations. So, as you can see here, that is by year, no? So, what is a time series graph? So, time series graphs plots observe values on the y-axis against an increment of time on the x-axis. These graphs visually highlight the behavior and patterns of the data and can lay the foundation of building a reliable model. So, visualizing time series data provides a preliminary tool for detecting if data is mean reverting or has explosive behavior, has a time trend, exhibits seasonality, and demonstrate structural breaks. So, in addition to containing a non-zero mean, time series data may also have a deterministic component that is proportionate to the time period. While seasonality is another characteristic of time series of data that can be visually identified in time series plots. Seasonally occurs when time series data exhibit regular and predictable patterns at time interval that are smaller than a year. So, an example of a time series with seasonality is retail sales, which often increase between September to December and will decrease between January and February. So, structural breaks. Sometimes time series data shows a sudden change in behavior of a certain point in time. So, as what we have here, no? So, in 1980, then going up, no? 1990 up to 2010. So, the time domain versus frequency domain model. So, two broad approaches have developed for modeling time series data. The time domain approach model future values as a functions to past values and present values. So, frequency domain models are based on the idea that time series can be represented as function of time using sines and cosines. So, this will be an example of time domain and the frequency domain examples. unvariate versus multivariate time series model. So the time series models may also be split into univariate time series models and multivariate time series models. The univariate time series models are models used when the dependent variable is a single time series, trying to model an individual's heart rate per minute using only past observation of heart rate and exogenous variables. Okay, so multivariate time series models are used when there are multiple dependent variables. So example, as what we have here, the data shows the change of variable over a period of time. An example is the annual population growth rate in a certain place, such as the data in table 20. So as what we have here. So it clearly one can say that the population continuously increased from year 1 to 9, and the appropriate graph for a time series data is a line graph. So this will be a sample line graph for the population of a region B. Types of graphs in statistics. So the type of graphs in charts, we have statistical, exponential, logarithmic, trigonometric, and frequency distribution. So the statistical graph or chart is defined as a pictorial representation of statistical data in graphical form. The statistical graphs are used to represent a set of data to make it easier to understand and interpret statistical information. The different types of graphs that are commonly used in statistics are here, no? So this will be, we have a bar graphs, no? Pictorial representation of data in the form of vertical or horizontal rectangular bars, where the length of bars are proportional to the measure of data. So, okay, so type of bar chart. So if the length of the bar graph is more, then the values are greater of any given data. So we have vertical and horizontal. When it comes to the vertical and horizontal, the two different types of bar chart are group bar and stack bar. So we have four different types of bar graphs. So vertical bar graphs, when the group data are represented vertically in a graph or chart with the help of bars, where the bars denote the measure of data, such as graphs, are called vertical bar graphs. The data is represented along the y-axis of the graph, and the height of the bars shows the values. While the horizontal bar graphs, when the group data are represented horizontally in the chart with the help of bars. Group bar chart, or called the clustered bar graph, which is used to represent the discrete value for more than one object that shares the same category. Stack bar graph is also called the composite bar graph, which divides the aggregate into different parts. Uses of bar graphs. It is used to match things between different groups or to trace changes over time. A bar chart possesses a discrete domain of division and more normally scaled so that all the data can fit on the graph. No? When there is no regular order of the division being matched, bars on the chart may be organized in any order. Bar charts organized from the highest to the lowest number are called Pareto graphs. So, example of a bar graph. So, to understand the above types of bar graphs, consider the following examples. So, savings and number of employees. So, this will be the bar graph. So, as what we have here, this will be the number of students, no? And then this will be the savings percentage. So, another example, of course, bar graph. same given data, but different graphs, no? It is also another way around. So the variation of temperature in the region during a year is given as follows. So defect it through the graph bar. So temperature, as you can see here, and then the month. So this will be the temperature at the lower part, no? This one, no? And this one will be the month, no? So from January to December. Histogram, this is a graph that displays the data by using vertical bars, no? To represent the frequencies. To draw a histogram, first mark the class on the horizontal axis and frequencies on the vertical axis. Draw a bar for each class so that its heights represent the frequency of that class. So the bars are drawn adjacent to each other. The frequency polygon, this graph display the data by using lines that connect points plotted for the frequency of the midpoints of the classes. And to draw the frequency polygon, mark a dot above the midpoint of each class at a height equal to the frequency of that class. Then mark two or more classes, one at each end, and mark their midpoints. Ogive, no? This is a graph that represents the cumulative frequency of all classes. So to draw an ogive, mark the class boundaries on the horizontal axis and the cumulative frequency on the vertical axis. Plot the cumulative frequencies at each upper class boundaries. No? Upper class boundaries are used since the cumulative frequencies represent the number of observation accumulated up to the upper boundary of each class. So, thank you, and this will be our references. Okay, so once again, good evening everyone. So next meeting, we're going to discuss about... So next meeting, what we're going to discuss is about the measure of central tendency, of course, and some part of probability topics. Okay? So I think it's already 8:30. So pasensya na po. Talagang even I wanted to meet you as early, no? Pero actually I'm available by 4 p.m. So if you wanted to adjust our time from 7 to 4 p.m., it's still okay with me. Okay? So once again, good evening, and thank you for attending our class. See you next meeting. So please post your suggestion if you want to have a class by 4 p.m. or still by 7 p.m. So good evening and God bless everyone.
Thank you,
Thank you
sir.
po,
Thank you,
Thank you
Dean.
po,
Dean.
Dean.
Thank you po, Dean. Thank you.
Thank you po,
Thank
Dean.
you po, sir.
Pwede na kayong kumain.
Apo, thank you.
Thank you po.
Salamat po.
Thank you po.
Bye-bye.
Bye.
Bye po.
Bye.